Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
So it's my pleasure to welcome Jacopo Staiano, my apologies, who's visiting us from University of Trento. And he's very interested in research in human behavior modeling, specifically with focus on affective computing. And today he's going to talk about some of very interesting work that he's done on social networks. All right, Jacopo.
Yeah. Thank you. So first of all, I have to prepare you that so this talk is the one I will give at UbiComp in a couple of weeks, and therefore it's quite short. So I will talk about this work, and then I will give you some hints on other works I've been doing lately. Actually, bear in mind that so this is involving data from smartphones, and afterwards I'll give you just a quick outline of a data collection we've been doing using wearable sensors, and then finally I will talk about a system we devised for user experience evaluation using a webcam. So there will be a jump from I to feel 1 hour somehow. So, okay, the title is basically what we try to do is we asked ourselves if there is any relation between the network structure between the social networks that a person builds around himself and is included within, and basically we asked how effective ego network structure features are in predicting users' personality, and most importantly, what are the benefits of using activity-based data versus survey-based data. So personality is seen as a static and internal determinant of behavior that means it influences our dispositions towards belief, actions, attitude formation, and it's often used to explain and predict behavior. The model we have been using is the Big Five factor model, which basically defines the 5 traits who are chosen as being the most orthogonal as possible. And those 5 traits are extroversion or introversion, which basically describes a person on his, her sociability versus shyness. Emotional stability versus neuroticism, so if a person is calm, unemotional, or anxious. Agreeableness or disagreeableness, so if it's friendly, cooperative, or as a fault-finding attitude. Conscientiousness, on the other hand, is a trait of people who are organized, while unconscientiousness are people who don't really care much, are inefficient in doing their duties. And finally, a trait related to creativity, which is openness to experience. So it distinguishes people who are intellectual, insightful, versus people who are unimaginative. So why we go for personality? We go for personality because it's linked to preferences and attitude. It's relevant for user modeling and recommendation systems. And it basically is a factor if you want to devise a perception system, because adoptions that I might take as an extrovert person are probably driven by different dynamics if I compare it to a guy who has a different personality than me. One thing we have I want to stress about is that so there's been previous works in both the social psychology and the social computing fields the main difference about these two fields is that while social psychologists use traditional social networks in the meaning that those networks are built using surveys in which you indicate friendship ties or relational ties with other people. From the social computer perspective, we instead use social events that are basically like a call I make to someone, or if I'm wearing a device that tells me that I'm around you right now. Those are events. Those are not, I'm not self-reporting that I'm friends or I know any of you, but there is a device that's logging somewhere that something is happening between me and the other people that are around me. So some previous works have found that psychological predisposition, so personality, are linked to ego network characteristics. Also, there have been works made on mobile phones very related to the work I'm going to present. So Chittaranyan and Gatika Perez found out that actor-based features, that means call durations, how many calls I do, can be predictive of the big five traits. On the other hand, De Oliveira and Oliver found that by using those actor-based features and augmenting them with the network structural features, you obtain significant performance improvements. So we basically had access to a database which was collected at MIT a couple of years ago, last year. It's composed of an international sample of more than 400 students. And those students are married graduate students living in a married student residency. And in the experiment, there is the student and his partner taking part of the experiment. So you have data also from people who's not really into that community, even though if you look at it, it ends up to be quite homogeneous. So this is one of the limitations I will talk about later. There's a vibrant community life, so social events, facilities, and there are some diverse sub-communities and social groups, like based on the ethnical or geographic provenance of the participants. So a rough view of the system that we use to collect the data, it's basically this. It's an application that is freely downloadable on Android systems. It's called the FunF. And basically, it allowed to gather some data, which I will describe in the next slides. And that data was augmented through the use of a Facebook app, which was getting information about the people who allowed us to do that. And importantly, the data we had was augmented with the buying habit, listening habit of the people who were participating in the experiments. Of course, all of these were complemented with the surveys that we used to submit to the participants. So the platform itself is composed of a number of probes, which are, let's say, the sensors for which with which it interfaces to the subject, and then there is applications. There is a market application. There is basically all means to know what the user is doing with that smartphone. So if I install a new app, how long it takes for you, my best friends, to adopt it too. If I keep using it, how long it takes it to spread over my, this is one example. And of course, all surveys notification were logged as well. So this work is based on the pilot phase of the study. So we isolated the pilot subjects, 53 subjects, were using were logged for 8 complete weeks. The data we used are the Bluetooth hits, call logs, and sociometric survey data. So the Bluetooth hits were basically derived from obviously the Bluetooth sensors, but they were filtered on the signal level in order to try to avoid as much as possible false positives. The Big Five questionnaire data was used to gather the ground truth for the personality traits. So from this data, we built 3 networks. One was based on call logs, the other on Bluetooth, and then we had the survey one. And we also merged the call and Bluetooth data by taking the intersection of the 2 networks, and so build, let's say, a digital a network based on the entire digital information we had, while the last one was built on the sociometric survey, which was basically by the traditional means asking what your relation is with the other people. Or so this is at a glance the distribution of the ground truth, which we had used to dichotomize. And we extract a set of features which are related to the structure of the network a subject was in. We focused mostly on the ego network structural features, because our hypothesis was that the structure of the ego network of a guy would tell something that could augment the prediction ability of a model. So we extracted centrality measures, small word and efficiency measures, and the triadic and transitivity measure. In particular, sorry, this is a fake slide. In particular, we extracted the standard centrality measure. Then we extracted the local efficiency, nodal efficiency, and then the mean local nodal efficiency of the ego network of the subject. And with respect to the triadic and transitivity measures, we extracted 2 different definitions of the triadic census. The first was formalized by Davis and Leinartz, and basically it's a count of different configuration of triplets in your own in the subject's ego network, while in the Kalish and Robbins definition, this configuration is based on a strong weak assessment of a given tie, and in a different configuration in which the ego would be present. Other than that, we calculated the clustering coefficient, the global transitivity, and the mean local transitivity, meaning the mean of the local transitivity of the alters of the ego I. So to give quickly some definitions, okay, the standard centrality measures are the degree, which is defined just as the number of alters an ego has. Closeness, I don't know if you're interested in this, but I wouldn't spend much time on this. So it's the inverse of the sum of the distances to the alters. Betweenness, eigenvector centrality, information centrality, which is the relative drop in efficiency when I is taken out. Then we have efficiency measures, which measure basically the response of the egonet when the node, the ego, is removed. And you have nodal efficiency, which is the inverted harmonic mean of the path length. So the closer the ego is to its alters, the higher is its nodal efficiency. And then we calculated values relative to the entire egonet of I. Finally, we computed the triadic measures that I described before and the transitivity measures. So our experimental setting was based on the 4 network types. So the network based on the call network, on the call data, the one based on the Bluetooth data, the merge one, and then finally the survey one. We evaluated 8 feature types. So centrality, centrality plus efficiency measures, transitivity, Davis and Leonard triad, a combination of them, up to 8. We had a binary classification task for which we used the random forest algorithm, and we used the bootstrap a bootstrap strategy. So basically, we embedded this in a leave one out setting. So basically, at each iteration, we will take a subject off, then 400 times resample the set, the data set that was remaining, and then using that one as training and to predict that the left one out subject. And this was suggested by a paper. Yeah.
What is the binary classification task for?
So it's basically for each trait. So you have extrovert or introvert. You have.
I see. So you didn't do like a 5-class classification.
No.
For access.
No, you have 5 binary classification tasks basically.
Got it.
And then we tried to explain our results by running some correlation tests and so global M-per-trait analysis of variance and some analysis of marginal means. So the results are, I will skip the boring tables and go more into the juice. So a global analysis of variance was performed. So we ranked the accuracy figures, and an analysis of variance was run on a design which was 5 traits by 4 networks by 8 feature sets that we defined. What we got out of this analysis was that basically the Bluetooth network and the centrality with efficiency features on openness and agreeableness were coming out as being the best performing ones. In particular, running a pairwise comparison on the marginals, you find out that this is the ranking of the, for example, for the network types, you will find that the Bluetooth network would be more informative than the merge one, than the survey, than the call one. Then regarding the feature set, as I said before, the centrality and the centrality plus efficiency were above the other ones. And with respect to the trait, then openness and agreeableness were over the extroversion and conscientiousness. Now, going to details, we ran 5 ANOVAs, so one per trait. And what we found out is that basically the network type has a significant influence on all traits, as you can see from this table. And the stable high accuracy of centrality measures, it's somehow counteract with the good performance of transitivity measures, especially on extroversion and Bluetooth, and on the other social traits, so agreeableness, as you see here, and openness, which kind of makes sense because those are social traits. So transitivity gives you a measure of how close together are your alters. So for example, this is a graph showing the performance on extroversion. The blue line indicates the Bluetooth network, and this is the peak over there, which relates to the transitivity set of features.
Quick one.
Yeah.
The Bluetooth is telling you how. I can go back one. The Bluetooth data is telling you how. Sorry, the chart.
Okay.
Yeah. So the Bluetooth data is telling you how extroverted they are, and how are you figuring that? Is that by how many times their Bluetooth is within the presence of other?
So basically, the Bluetooth data is telling you. So we use it as a proxy of for proximity.
Okay.
And basically it was, so the smartphone would act in an opportunistic way. So each, at least every 5 minutes, it would sense who is around and log them. And then as a post-processing step, you would use some filters to eliminate a lot of false positives, because with Bluetooth you have like a 10 meters range or so, and if you have a really tiny wall, then you also have a hit. But then if you filter by the signal level, for example, and you can get a decent approximation of the proximity network. So, for example, one result that came out was that basically, as you can see, the extroversion, for example, now here we're focusing on the peak we've seen on the previous slides, so extroversion on the Bluetooth network. And you can see there's a positive correlation between extroversion and the complete triad, let's say. While it's negative otherwise, and this just makes sense because it's a measure of the clustering coefficient. And we explain these values by saying that probably extrovert people like to, let's say, filter out people who don't fit in their network. So like extrovert people are probably better off with the other extroverts, which also somehow makes sense. And it's actually supported in the literature by a work from Alinan and Kubitschek. So they show actually that friendly students, so extrovert students, show a lower tolerance for intransitive triads and tend to remove them over time. So this might be an explanation of the results we got. We also tried to compare our results with the actor-based features we had. We couldn't directly compare with other works, for example, the one by Gatica Perez, because in our data we only have hits and we don't have for example, the duration of a call. That's not represented in our data, unfortunately, so we couldn't really extract all the features they used. Anyway, we extracted all the features we could from our data, and what we found out is that basically the network-based features, always led to better results on all traits. Turning to the limitation of this work, one is definitely the small sample size, because we only have 53 participants. The population is quasi-homogeneous, and importantly, we have no logs about interaction data with non-participants. So we can't really tell if a guy has a really sparse network because he just doesn't use his phone for calling, or because he only calls people who are not participating to the experiment. So this is a pretty strong limitation to our work. So the takeaway messages are that basically the structural network features are important for personality studies. The data, activity-based data, seems to be more informative than surveys-based data. And triadic transitivity measures are very relevant for extroversion, especially on proximity networks like the one we built on the Bluetooth data. And centrality and efficiency were relevant for neuroticism and agreeableness. Overall, on all traits, but on neuroticism, the proximity-based network was more relevant than the one built from call logs. So this is the first part of the talk. I don't know if you have a question on this. Then I will go on with the other.
you actually answered this, but I might have missed it. So for introverted people, if you look at their like local social network, would their social network graph have lower diameter than extroverted people?
Sorry?
Would the social network graph of someone who's introverted have a lower diameter than that of someone who's extroverted?
A low diameter, so you mean
tighter.
they are more, yeah.
Here.
No, it should be the opposite, I think.
Should be the opposite.
Yes. I guess it should be the opposite, because basically, if we go back to this one, so for example, here we're talking about extrovert people, so the opposite of the introverts. You either are on one end of the spectrum, and it's very negatively correlated, for example, with, let's say, this setting of triads, or this one, let's say the non-closed triads. So I expect no, you're right, it would be longer. You mean the diameter?
For extroverted, would be longer for extroverted people?
No, for introverted, you mentioned that, right?
Yeah, I said the other way around. So the diameter for an introverted person, should be, I feel should be shorter or smaller, and for an extroverted person, it should be wider.
Yeah,
So it's the opposite of that?
yeah, our results suggest the opposite.
Why is that?
Because it looks like the extrovert have a tighter network, so the diameter is shorter, right?
Yeah. Okay. It feels like.
So that means if you have a sparser network,
I feel like if someone's extroverted, they should they
Keep
more than
with-
likely make friends quicker and with more wider groups, so they have a longer path through their social network. Like they have more disconnected components in their social network.
so introverts should have a bigger diameter. I mean, by diameter you define the.
Yeah, but my point is, if someone's introverted and they have a small close group of friends who are all probably connected to each other, so the diameter is probably lower.
All right. Yeah, that can be a case too.
Okay, so your result is opposite of what
Yeah.
I was intuiting.
I think what you're saying is like extroverts, friends, all like they friend people who also know each other.
Yes.
So it's shorter because it's more tight.
Before it's more tight, yeah. So that would be my intuition. His results are opposite of what my intuition is. So I was curious.
Yeah. So if there's no more question on it, I'll give you. So I'll give you a quick glance of the actually our latest work, which was basically a data collection we ran with wearable sensors. So the sensors are the one you see in the pictures over there, and the sociometric badges. And those sensors are equipped with a microphone, with a Bluetooth, and an infrared sensor, and an accelerometer. What we did, again, is that basically we recruited a volunteer, actually entire research units in a private research center, and we gathered 55 participants over 6 weeks. They were wearing these badges Monday to Friday on working hours, and we used an experiential sampling strategy so that every day, 3 times a day, they would receive on their mobile phones or on their email box a short questionnaire meant to be like 2 minutes, 3 minutes, and so we have a bunch of variables logged into survey data. We have the phone and email logs, and of course the sensors logs. The data we get is behavioral from the badges and from the mail info logs. So how people interacts with each other by technological means or physically, in the case of infrared sensors that detect, for example, the face-to-face communications. On the other hand, we have the survey data, which are pretty comprehensive, and they include personality, affect and loneliness, creativity and productivity, and situational items, which we will use in order to reconstruct the mood, the context in which the person was acting within. So this was just a quick glance. And now I will turn to a paper I presented a couple of months ago in Newcastle, which is quite different from what said before. It's still related to behavioral analysis, automated behavioral analysis. In this case, instead of using smartphones and data gathered through mobile phones, we use basically a webcam, and the user is actually a subject testing a new prototype for a software system, so a novel interface. So in contrast with the picture you have on the left there, in user experience studies, the emotions which are listed are typically low intensity, mixed nature. They are dynamic and simplified. The research goal for this work was trying to understand how emotion-based measures could support user experience evaluation. Try to find a validation for new measurement tools, and the overall goal was basically to build some non-intrusive methods in contrast with EMG, for example, to stick on the subject's face in order to exploit emotion in user experience evaluation. So emotions are used to be measured in different ways. One way is the questionnaire measures, which has pros and cons. So it's on one hand, it is ecologically valid. On the other hand, it doesn't capture interaction dynamics because it only happens afterwards when the interaction is over. On the other hand, psychophysiological measures like EMG sensors have the benefit of capturing interaction dynamics, but on the other hand, they require expensive equipment, and they're not ecologically valid because you have to call a subject, call him in the lab, stick the stuff on it which might bias him, and so on. So what we propose is a system that basically automatically monitors the emotional state of the users during the interaction. It is cheap in the sense that it only needs a consumer-level webcam and a computer. It's non-invasive because there's no sensors attached to the users, and it can potentially be run at the user's place. What is provided by the core of the system is basically the detection of minor changes in facial activity during the interaction. So this is how the initial prototype is designed. So in a very simple way, there's the user in front of the camera. The camera gets the video feed. There's the module who tracks the facial motion, and those facial motion features who are extracted, they are indexed. So basically, there's a post-processing step. Then there is we devised a calibration phase and the prediction phase. Basically, in the calibration phase, we followed the literature and designed two really quick tasks who were prone to elicit the reactions that we wanted to predict for automatic UX assessment. So I will go into details now. So the facial features are based on the seminal facial action coding system by Ekman, which in '78 defined a set of more than 40 action units that are responsible for building facial expression taxonomies. Our system uses motion units. Motion units basically are a subset of those action units, and the relation between motion units and action units is that while action units gives you a coordinate of a certain point in time, our system gives you also the magnitude component, so the amount of distance you had from the previous position to the next one. So this is an example that shows the muscles on the face of a human face, which are the most important muscles in very bad resolution. Okay. Anyway, this is what the system looks like. This picture here only shows that it works, that it used to work with really low-fi cameras, which are not in commerce anymore right now. So that's a good thing. That's how it looks like for real. And now I'll show you a video. So this is the tracking system in action. So basically, how it works is that it fits a 3D mask on the user face, and basically we use it in order to track certain points, which are the ones that the joints of the face, which are most related with the changes in the facial expression. Like this one is an impression that we want to take. We want to detect exactly those kind of things while the user is playing with a new interface. There should be another one. Like this. So we think those are signals that might, convey some information about the problems the user is experiencing with your new interface. Okay, so basically, sorry for the mess with the video. So basically, we have our focus was on usability, and in the literature we found out that some combination of features, facial feature motion were found to be correlated with confusion and frustration. And since those were relevant to our study, we decided to basically, following the literature, to build compound variables over the features that we had, so linear combination of them. And so we computed also indexes for confusion and frustration. But it's important to say that we don't want to detect frustration or confusion. We only use previous works in order to build a new feature based on the features that we extract, and then go on with it. The activation indexing stage that I spoke before, basically it uses a technique which we found in literature to be very common on EMG signals. So basically, a feature would be considered active at a given frame in time if its value is above its mean plus the standard deviation value. So we stick with that definition, and we post-processed all the features extract, and that's how we built our vectors of features. So we ran a couple of studies for this software. And the first one, we used 15 master students who had never used for a set of 4 media players that we chose. We gathered performance measures and user experience self-reports. And of course, we got UXMate output from the video data. What we found is that there were significant correlations between the data we extracted and the number of errors. We identified which were the relevant motion units, which were mostly related to the mouth corners and the eyebrows, as expected. There was a weak correlation between subjective evaluation and the number of errors, and it looked like the questionnaires were biased by the last task, which was the most challenging. Also, there was a strong inter-individual variability. What we also did is that we took 1/3 of all the face videos that we recorded, and we gave it to 3 observers and asked them to do UXMate's job, to see if she could say, okay, the guy is experiencing some difficulties. And what turned out is that 2 of them were kind of random. One was performing well. So we asked her, "What do you have any specific training on the fax system, on Ekman's coding system?" And it turns out she had. So we were like, "Okay, this might work," because I mean, if you were random as well, then it does make sense that we try to make a system that approximates that stuff, and then. But this actually gave us a motivation to further investigate the problems. So we designed a validation study with twice as many students. So we got 31 undergrads. We used 3 academic social networking websites, because we didn't have the resources to build the interfaces, and so those were Academia, I'm Researcher, and ResearchGate, and we introduced the calibration tasks. So we designed 2 tasks in order to get basically the training data for building our models. And both the screen action of the user and the synchronized face video have been released, so they are online for if someone wants to work on it. So this is an example of the calibration phases. So basically the guy would the subjects would be randomly shown this sequence, either first that one or first that one. The order would be random. And here, following 2 lists, you can see that while one is cluttered over there, so it's most difficult to find a double room at the Holiday Inn in Bradley in that setup, rather than in this setup where everything is like, visually organized. So we use this in order to gather our training set. This is an example of what happened to the guys. So that's what the guy is watching. So the non-cluttered one. That's, So there's something there, and actually when we checked the numbers we had, we found that, so these motion units are the ones related to eyebrows and to the mouth corners. Those are the compound ones that I talked before, the frustration and the confusion one. So you can see that in the difficult condition, there's higher activation levels of the facial motion. So we built our models. We tried to predict using only the calibration phase data. We tried to predict the actual experience of a user on the 3 networking website. Results were not so great, even though not either too bad for a first run. So we plan to actually improve UXmate, and this can happen, for example, in trying to fit better calibration tasks more suited for what you want to detect on the real on the real tasks. Probably we should extend this to other interaction feelings. For example, engagement during video games might be an option. And probably new compound variables needs to be identified in order to extend it. So after all, this is probably your face now. Well, you. So the outline is that we presented a cheap, non-invasive way to try to get automatic user experience assessment, and we released the database, and hopefully someone will use it. So that's it now.
Do you feel that there's room for improvement in terms of the actual markup of facial features? Do you think that tool is good enough? And I'm sorry, I missed a little bit how you developed that tool or where that comes from.
Okay, so I think there is. The tool does a good job, but right now I think in that field you have a lot of tools that do actually probably also a better job. So. From a research point of view, I would go in improving that tool because there's not much research in it.
Yeah, even just looking at the video, for example, looked like it wasn't looking that much at the forehead, where it looks like a lot of these kind of confusion wrinkles are. So, yeah, I don't know. What we're looking at here, how how do you pull the actual numbers out from?
So basically what the number represents
Yeah.
is that at each frame you will have a displacement
Okay.
which give you the direction and magnitude of a movement of a certain facial feature point with respect to an initialization point, which is the moment before the calibration task there was a cross on the thing. Please stare at me. Screenshot. But yeah, I mean, this system is not perfect, but it works reasonably well for our purposes. It's true that there are a bunch of other systems, also commercial systems, or I mean, think at the ones that Google has, Microsoft has, Facebook has. I mean, they're for sure 10 times better than this one, but we don't have access to them. So.
Have you considered like how this thing will play out in like more natural settings instead of like this is fairly artificial, you bring people in?
No, this is okay. These some of them are run in the offices, but
He always is like that.
huh? Oh, you mean Patrizio here, the guy?
I mean, it seems like, I don't know, it seems like there aren't much distractions. The person is really like doing what they're doing, right?
Oh
But
yes.
in more natural settings, it might be more complicated, where you are in a social situation and there are multiple different types of signals that you're exposed to, which
Yeah,
could,
more noise. You mean?
yeah, which I mean, and then detecting emotion from facial features in those type of environments. How that? Do you have any ideas? On how
Well, the thing is that here the whole point of this is to have some evaluation of a new interface prototype that I have. So I would call people in and say, hey, with what we foresee is that with a system like this, which can run on your laptop, I can just give you access to my interface prototype and tell you, hey, do it at home when you have 5 minutes. You go there, you do it. Of course, if you start drinking a coffee and doing other stuff, then we will get random results. But yeah, it's the trade-off with the ecological validity here, and
right.
How much does it depend upon the? I mean, if I move the camera from here to the top of the monitor.
the camera is on the top of the monitor.
Oh, is it on the top of the monitor?
Yeah, this is a laptop like this, so you have the embedded camera.
I see.
The people are really having bad ergonomic setup.
Yeah, I know. Yeah, I mean, it seemed like that. But how sensitive is it to? I mean, well, I guess all the laptops have the cameras over there, but.
You mean on the position of the camera?
Yeah.
Well, I mean, I would say like you have at least, I don't know, if you talk about tilt, I think you have a kind of a.
What about like if I distance? Is it robust to it? Because
Yeah.
it's going to
I mean,
change my perspective.
it gets up to, I would say, I think this distance, like 1.5 meters from the camera, should be fine. And the problem is with the partial occlusions. Like if you start to do this, I mean, the tracking would still be there. It is quite robust to it, but you should filter them out because you don't need that stuff.
I'm just wondering, so do people actually show a lot of expressions during these tasks? Or
It's low intensity.
yeah, so I'm just wondering,
Expressions.
is it worth spending effort in facial expression analysis when people are, I mean, there are other things that you can do, right? You can look at maybe their keyboard movements, maybe some physiology. That might be easier signal than something so hard. Just a thought.
Yeah, probably. But I mean, the idea was coming from an HCI professor in our end. She was like, look, evaluation studies are usually done with 2 MG sensors, one on the head and one on this. And what do they measure? They measure the activation of those muscles, which we can't really measure, because if it's not visually, you can get it with a webcam.
Actually, the psychology literature, there's a strong body of work around facial features and emotion like Paul Ekman. You cited that stuff. But I think you're right. I mean, that was the pre-computer use time, so it's not clear how those things play out in today's information world. So maybe like if you're like you have those badges, so if when people are interacting with each other, it seems that people will be more expressive with their facial expression because they're trying to communicate a certain thing to a different person. So in those kind of situations, these might be more explicit.
So for example, for this, for this study, so you have both the videos of the guy and you have the video of the screen of what the guy is doing, because that's what annotators used later to say, hey, he didn't take the right path to upload the photo over there. But of course, I mean, you could have, I mean, you could devise your interface prototype, whatever, in order to log if the guy was doing wrong actions. Then you wouldn't need facial expression, you wouldn't need, it would be a self-contained story.
Have you thought about just running this over time while someone works and logging how they feel throughout their, so I know that I get passively frustrated. I don't realize that I'm frustrated when I'm working. It'd be really interesting to go back and see that I was frustrated when I was writing this email, or when like this person texted me, or something like that. You thought about saying that?
No. I
Like
mean, what we.
self-reflection mechanism.
Because
You think you'll find people to participate in experiments like that?
I think people would be interested in doing it for themselves, right? So I think in the social setting you have a more loudly expressed facial, you know, communication. But I think on your own you have a more honest one because there's no one there, so you probably
You're less biased.
Yeah.
I have a feeling that when I'm on my own, I don't like. But I may be wrong. It might be like a subconscious thing.
See, I feel that way, and then when someone walks in, I'm like, oh, I must adjust my face.
There was a guy who did like an art project where he constantly took pictures of himself, and he got in a lot of trouble because he took pictures of. He got all the laptops at the Apple store in Manhattan to like record everyone, and he got in a lot of trouble. But he said he wanted to do that project first because he recorded himself, and he found that he didn't have any change in facial expression. So that kind of goes along with what you were thinking, that people don't really change their facial expression that much. But it's one example.
Right? Thank you. I'll go again.
Okay, thank you.